How you going, guys? So today we're looking at increasing and decreasing functions. So what does that mean? When we're talking about increasing and decreasing functions, what we're actually looking at is we're looking at when is the gradient increasing and when is the gradient decreasing. So this here is when we're all looking at how does the gradient change according to the function that we're looking at. And the best way to be able to work that out is by using tangent lines. So if we take tangent lines of different types of functions, so for instance, if we take a tangent line of this function here, 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 at different points on this graph, we can look at, well, how does that tangent look like in terms of a gradient? So if we go back to what we know about gradients, that we know that positive gradients are going to go from left to right up. So we know this here is a positive gradient. And we know that negative gradients are going to go from left to right down. And then we have the zero gradients, which neither goes up or down. We can use our understanding of how the gradient works on linear functions in terms with our gradient or tangent lines. So we can see in this first equation here that this here has a decreasing gradient until it reaches a point where we're going to call zero. It's from zero, or when it goes past zero, it starts increasing in function or in gradient. So this here is what we're looking at in this series here, is when is this function increasing or decreasing? So we can look at this here in terms of looking at a sign diagram as well. And we generally draw up a sign diagram of what the function is going to be. What we identify is, well, what are the points that are where it changes in terms of gradient according to the x-intercepts or the x values. So in this case here, 0 is where this changes from negative to positive. So that becomes a critical point. Now when it comes to looking at functions in terms of graphs, visually easily to do. Okay, you can see where it's decreasing and increasing. However, you are expected to do this with algebra as well, and that's where it gets a little bit tricky. Okay, but we can look at and use sign diagrams also with the algebra when we get to that, and we'll look at that in our next video. In this case here, we can say, well, before it reaches 0, I have a decreasing function. And once it gets past 0, it's increasing. So the sign diagram should replicate what the graph should look like in terms of its gradient, where it's decreasing to where it's increasing. And then we have another way of writing this, is this using interval notation. So interval notation is when we're looking at, well, how does it change in respects to x? So we can say here that it's decreasing when x is less than or equal to 0. And then we say it's increasing when x is greater than or equal to 0. And again, this here complements your sign diagram, which complements what your graph should look like. Now, in these instances here, nice and straightforward, there's only going to be one critical point because it's only changing in one direction. However, in this example here, we can see that we've got two critical points. We've got the -2 and the 3 where it's starting to change its direction. So in this first part here, we've got a positive gradient. It's positive, so therefore it's positive until it reaches 2. It then becomes negative until it reaches 3, and then it's positive again when it reaches after 3. So again, we can sketch up a sign diagram that represents all this information. So if we put our sign diagram down here, we've got our critical points. Where does it change? Basically, that's when you equate it to 0, when the gradient is equal to 0. Because at the gradient equals 0, that's where you have no change in gradient at all. That's where it's changing from positive to negative, or in some cases you go from negative to negative, positive to positive. But it will have a non-inflection stationary point at that point. So if we are going to be doing our sine diagram, then we just plot down the critical points where it's equal to 0 for that gradient. And again, we just look at the curve and we say, well, in this case here, before it reaches -2, it's going to be positive. Past -2 all the way down to 3, it's minus, and then after it passes 3, it's positive again. So we've got our graph that's telling us in terms of our gradient how it works. We've got our sine diagram which relays a different way of actually showing that, that movement in terms of gradient. And then we've got our interval notation. So down the bottom here, let's do the decreasing first. So decreasing, well, because we've got between two values, what we write here is -2 is less than or equal to x, which is less than or equal to 3. So between, remember when we're doing interval notation, when it's between, we have less than or equal to. The only time that this here wouldn't be less than or equal to would be if we have a continuous graph, or if we have an asymptote, where in this case here, it wouldn't be touching 2, it would just be less than 2, between less than or equal to 2, but not touching -2, to 3. But in this case here, we don't have that asymptote, so we can leave it as less than or equal to. When it comes to increasing, we have 2 points. The first point is, well, when x is less than or equal to -2, that is when it's increasing. Or it's increasing when x is greater than +3. So there are 3 different ways we can show increasing and decreasing functions. Remember, we're looking at the gradient. In these examples here, we have the visual cue. We find the gradient by looking at that tangent line, matching it up with a sine diagram, which then is complemented by your interval notation. And a lot of times when you get questions, we'll ask you, give us the points where the graph is increasing or decreasing. It's asking you to do the sine diagram and then double it up with your interval notation. So that's what increasing and decreasing functions all about. Next video, we're going to do a few examples without graphs, so that way you can see how we do it algebraically, which is the most common way of doing it. I'll see you then.